Welcome everyone to the Ideas Seminar Series. I'm delighted today to introduce our speaker, Lieutenant Colonel David Beskow, who is a newly minted PhD. He will literally be graduating in our ungraduation ceremony this year. And he is from the Army, and his background is in operations research. His work has been looking at social media analytics, particularly focusing on new techniques for identifying, culprits of interest, such as bots, things of interest, such as memes, and so on. With that, I'm going to turn it over to our new Dr. David Beskow to give his first talk with his PhD.
Good afternoon. As Dr. Crowley just said, I'm David Beskow. Just finishing up my PhD here at Carnegie Mellon University's School of Computer Science. Over the next 50 minutes or so, I want to present social cybersecurity research and applications with some applications, some initial results, at least from using this in the COVID-19 crisis that we as the world are facing today. Before I get started, I want to thank some of the funding resources, both the United States Army for the opportunity to take 3 years and pursue a PhD here at Carnegie Mellon, as well as research funding to support some of the research you're about to see. I also would like to thank the Knight Foundation, as well as the Office of Naval Research under the Department of the Navy for their contribution to this research effort. So without any further ado, let's get started. Alexandra and Anna entered a new country in June 2014. They came to understand that country, its varied communities and cultures, its narratives, and its stories. Their trip, however, was not motivated by natural curiosity. Rather, it was their goal to sow discord in that country. Alexandra later became a senior manager in what became known as the Internet Research Agency, a St. Petersburg-based company that conducts disinformation on behalf of the government of Russia and Russian business entities. Both were later indicted by the FBI as part of what became known as the Mueller investigation. This is Foreign Minister Zhao Lijian. He was one of the earliest Chinese foreign ministers to embrace Twitter, and unlike traditional Chinese information operations, which primarily relies on positive narrative pushed by the 50-cent army, he has adapted a confrontational approach more akin to Russian information operations, and has gone toe-to-toe with senior U.S. ambassadors to include Susan Rice. In February, he was promoted to the spokesperson and deputy director of the Information Department for China's Foreign Ministry, indicating a Chinese desire to adapt a more confrontational approach to their information operations. On 12 March, he took to Twitter to spread the conspiracy theory that the United States Army started the coronavirus that we see raging across the world today. And within hours, it was viewed by over 160 million times. In our analysis of the accounts pushing his messages, 65% exhibit bot-like characteristics, indicating a sophisticated supporting effort. Just yesterday, 6 April 2020, Iran initiated a concerted attack on the United States focused on the CalExit hashtag, trying to encourage the California to exit the Union. By the time the dust settled early this morning, approximately 30,000 tweets have been launched by several thousand strong bot army. Why are these nation states and many other entities conducting these types of operations? The reason lies in the fact that the borderless internet has made it easier and much more effective to hack people than systems. In the 1800s, Karl von Clausewitz defined war as politics by other means. Today, one of those means is information warfare. This warfare has led to the emerging field of social cybersecurity. A large part of the research you're going to see today has been to define this emerging discipline of social cybersecurity. It differs from traditional cybersecurity. In traditional cybersecurity, you have individuals, people, using computer systems to attack other computer systems and the data that lies in it. In social cybersecurity, you have oftentimes similar people using those same computer systems to hack other people and the society that binds them. It's different because you bring the entire human complex and the social connections that people have into this very difficult and messy problem. This will be briefly look at the agenda. I've kind of divided this into the paradigm through which many military leaders view the world through strategic, operational, and tactical lenses. For those who aren't familiar with these lenses, at the strategic level of war, it's primarily concerned with the art and science of employing national power. We oftentimes define national power by the elements of national power, or the DIME paradigm: diplomatic, information, military, and economic elements of national power. We want to understand how, in the context of continuous competition, information is increasing its market share within the DIME construct. The operational level of war, in the middle, is concerned with planning and conduct of campaigns. At that level, we want to understand how do enemies and entities maneuver in information space in a similar way that they maneuver in the physical space in traditional combat. The tactical level of war is concerned with the planning and conduct of battle or engagement. This is where entities conduct conflict. In this level, we've conducted a number of computational battle drills to identify and dissect emerging threats. For the sake of time today, we're primarily going to dive into the bot and meme hunter, and I'll briefly discuss the other algorithms in a very short summary. All of this is conducted over the modern information environment you see highlighted in the bottom there. Let's start by defining the strategic context. As I go through each of these kind of sections, you'll see a few of the articles highlighted through which we've published some of our findings and research and salient research contributions. Within the strategic context, the big defining backdrop to all of this is increasing competition across the elements of national power. You see this highlighted here in the United States 2018 National Defense Strategy, which was primarily architected by then National Security Advisor McMaster. That interstate competition, not terrorism, is now the primary concern of US national security. This idea of constant competition is relayed by the senior leaders on the other side of the Atlantic, in this case by the Chief of Staff of the Armed Forces of Russia, in slightly different terms, but the same idea. We are currently at war. All of that conflict or competition is happening across the elements of combat power. Once again, those are the diplomatic, information, military, and economic elements of combat power. We see the information element increasing its market share, primarily taking from military and to some degree the diplomatic elements is primarily where it's coming from. And you can see here, even defined here by the Russia Special Purpose Forces, that this type of warfare has emerged and is taking over as the decisive place in the achievement of military and political objectives. What has changed to allow this? While influence operations date back to the beginning of time, they have typically required some level of physical presence. For nation states to pull off large influence operations, they require boots on the ground from intelligence organizations. But today, the borderless internet means that this is largely unnecessary. Second, it's easy to start a new community. Going back to antiquity, there were communities that you were largely born into. You were born into a tribe, into a family, and you were kind of stuck with that community for the large part of your life. Today, as Facebook liked to advertise during the recent Super Bowl, it is easy to start and join new communities. Communities, by their very nature, help shape identity, they shape beliefs, and to some extent, individual and corporate action. Since these are now easy to build and better, even easier to infiltrate, they are being leveraged for influence. Today, everyone has a voice. In 2010, this was trumpeted as a great good that the internet has brought us. Today, we're beginning to step away from that and wonder how good this is truly to allow everyone to have a voice. With everyone having a voice, it means that the normal gatekeepers have been removed. And traditionally, your large media companies were the gatekeepers to getting things out to large audiences. 30 years ago, the leaders of the Flat Earth Society would have a hard time getting their opinions into the New York Times opinion piece. However, today they can start a Facebook page which has 250,000 followers and likes of people who are either believe or interested in exploring the idea that the Earth is flat. Once again, the filter has been removed. The gatekeepers is down at the consumer level. The actors that are leveraging this are many. As already alluded to, nation states across the world are leveraging this fact. They are also using closely related front companies. Redfish is a Berlin-based media company producing fairly professional media artifacts that are, but it's the Redfish is backed by the Kremlin. So these are front companies that are producing propaganda on behalf of nation state actors. You have gray and black marketing firms. Much of this information is highly successful and highly lucrative, particularly if you can inject AI into it so you don't have to pay a large army of trolls. If you can remove the large army and simply have AI pushing it, there's a large margins in this market, and gray and black marketing firms are taking advantage of that. The picture you see here is a black marketing firm that was pushing a lot of propaganda for local domestic players during the Mexican elections. Terrorist organizations have used this through the last decade and beyond. Political entities of all shapes and sizes are leveraging this, both overtly and covertly. And then you have the entrepreneur. This is the Macedonian high schooler who realizes that they can make $10,000 if they can get something to go viral, regardless of the veracity of that narrative. There's a number of desired effects. I'll focus on the desired effects primarily that the nation states are looking at. One is to make truth elusive. This is particularly conducted by Russia as well as other actors. This is a Russian meme. You see here they're attacking mainstream American media. We believe the primary reason they are doing that is in order to make truth elusive. If truth is elusive, a couple things happen. One, alternate narratives can rise. Two, in democracies governed by consent. In order to get consent, that nation's populace needs to understand what the truth is so they can have consent. Without the truth, it is harder to gain consent, and that nation will not be decisive on the world stage. Secondly, to create geographic division, I've already alluded that Iran just tried this yesterday with what is known as Calexit. They also focus oftentimes on Texas with what is known as Texit. The reason they do this is California is roughly 14% of the US GDP. Texas is second and contributes about 9% of US GDP. If either one of them left the union, it would largely create a largely different strategic stage for the balance of power in the world. Regime change. Russia defines regime change as the destruction of the organs of government. Short of the destruction of organs of government is hacking an election, as you can see here. Intimidation, we'll talk a little bit more about this, is an emerging way that they are used. Creating social division, particularly Russia, and to an increasing extent China and others, try to identify every fissure that exists in a society, and then trying to drive wedges to increase the division and the divides in those fissures. Finally, to strengthen allies among those parties that may have kind of similarly overlapping goals. We'll kind of start going down now into the operational level. Once again, the operational level is looking at the how do entities conduct campaigns. What does an operational campaign look like? We've published this in several articles that you see here. The overarching contribution that we have here is that in order to understand a campaign, you must understand what the adversary or the entity, the actor, is conducting in both networks and narratives. Traditionally, people have focused on only narratives. We believe that you have to understand manipulation and maneuver in network and narratives in order to be complete. Traditionally, Ben Nemo and his team at the Digital Forensic Labs used the 4 Ds of dismiss, distort, dismay, and distract to define information maneuver. These were extremely effective at defining Russian maneuver, particularly as they attacked various narratives on the world stage. However, while helpful, we don't think it is sufficiently to define it all. We believe that, as just noted, that maneuver is in network and not just narrative. So we defined what we call the full bend paradigm. You can see the acronym, how it's broken out here. On the left, you have network maneuver, those maneuvers which are attacking or supporting network, supporting on the top, attacking on the bottom. And on the right, you have the narrative maneuver with pro-narrative maneuvers on the top and con or attacking narratives on the bottom. Once again, our contribution is primarily to contribute the B, E, and N here. The 4 Ds we've taken from the original 4 Ds developed by Ben Nemo and his great team there at the Digital Forensic Labs. So I don't have time to go through all 16 of these and give examples. What I'm going to try to do is take one example from each of the 4 bends that you see here. First off, we have the build. This is, for those who can't read this, this is by @HoodedMan, a Twitter account that's tweeting here that says, "Stop military exercise Trident Juncture 2018 in Norway and Scandinavia." And it has a picture, allegedly in Norwegian, posted on some kind of lamppost that's trying to draw anti-NATO and anti-NATO protests in the Scandinavian peninsula. This is a sophisticated cyborg that has some elements of automated bot activity, and it's attempting to build both virtual and on the ground grassroots anti-NATO protests and sentiment in Scandinavia, particularly in the run-up to the 2018 Trident Juncture exercise, which was the largest major NATO exercise ever in Scandinavia. This is an example of a build operation. Here's an example of an explain operation. This is conducted by Redfish, a Berlin-based media company backed by the Kremlin. This is a very professional done documentary of what they're calling foreign intervention in Iran. This documentary was released in the aftermath of the assassination of Soleimani, and it's trying to highlight Western manipulation of Iran to capitalize on the world events at that time. This is an example of an explain information operation. Here's an example of narrow. This is an Iranian proxy account that's attempting to narrow the number of allies the United States has across the world. This that publishes what they call U.S. manipulation and infiltration and interventions across the world. They're trying to narrow the number of allies and partners that the United States has. This is an example of a narrow exercise. And finally, this is an example of dismiss. In this case, the Russian embassy is using humor to dismiss accusations that the British government had after the poisoning of Sergei and Yulia Skripal. This is a very classic Russian dismiss. Notice here, this is coming from the Russian embassy in UK. The Russians at times use their embassies as overt propaganda mouthpieces, and in this case, almost trolling at times. So this is what you see here from the Russian embassy in the UK. We note now that this BIN framework has been instrumental in helping both analysts and leaders understand and synchronize lines of effort that work together to achieve political ends. Even as we speak, analysts in the DoD are beginning to categorize threat maneuvers into one of the 16 BIN elements, and the BIN framework has been incorporated into advanced military education. So with that, I'm going to transition down into some of the tactical levels. The first tactical tool we've developed is kind of what we call Bot Hunter, and it's focused on bot detection. Bot detection is an important part of the social cybersecurity workflow. Bots, which we'll define momentarily, are generally used as force multipliers in information space. Their detection becomes an initial step in finding and outlining a campaign. If we find the boundary of where the bots are operating, you will often find the boundary of the operation itself. So first of all, what is a bot? A bot is any activity that conducts its account activity with a computer. On Twitter, this can be done by posting, retweeting, liking, replying, all the things you can do on the front end, you can do on the back end with a computer at scale. Sometimes, in just a second, we're going to classify these into either a bot or a human. I do want to highlight that an account can have both operating at the same time. For example, a computer could be conducting scale operations at scale in the background, while a human hops on that same account on their iPhone to conduct a nuanced dialogue. Accounts that have both operated on the same account, we oftentimes call hybrid or more often cyborg accounts. I do also want to highlight that not all bots are negative. We're about to talk about a whole bunch of malicious bots, but there are positive bots out there to include personal assistants, bots that notify people of natural disasters. There's also bots that we call neutral, and those are generally in the category of some type of spam bot. And finally, malicious bots, which we'll discuss a little bit more here in the next few slides. Here's an example of a malicious bot. This is from the Middle Eastern context. This is in Arabic, has a very professional looking profile image. But if you break out the retweets content versus the original content, you will see that every retweet is anti-Saudi Arabia or anti-Saudi Arabia coalition content. Every original content is what I call dumb original content. For those who can't read the slide, the two tweets here are translated, "No one can understand me anymore. Your morning is beautiful." This is kind of this dumb original content, which you can picture that they have a data file, a CSV or some other text file that has 1,000 or so of these dumb tweets that they grab at random intervals and interject into their stream to make it try to make it look more human. This is an example of one kind of malicious bot. There's lots of types of bots. One that we've done some research on that very few others have focused on, and that's they look very different than other bots, is what we call intimidation bots. How an intimidation bot works is they, in large numbers, will follow certain people in order to push them off of Twitter. A bunch of them we've found following freelance journalists in Yemen. So as the various actors that are in conflict in Yemen are trying to conduct operations, and at times they're trying to get away with what most people would call war crimes. In order to do that, it's hard to do that when you have freelance journalists bringing the truth of what's happening on the ground out to the broader world. So at least someone, the actor, we haven't determined exactly who it is attacking these freelance journalists with these armies of intimidation accounts. These accounts have very intimidating and sometimes grotesque profile images. You can see in examples here. And then they often have content that is very threatening. In this case, this one has a pinned tweet that has a video of a woman being killed by a sniper attack. And the translation of it, it says, the pain is that it suffocates your heart and you cannot scream, #sniper. This account began following female, in this case, it was an award-winning Irish freelance journalist who's on the ground there in Yemen. And it wasn't just this account. When this account started following, it was part of about 10,000 accounts that started following her, many with very grotesque images that I would not be able to put on these slides here. That's an intimidation. These accounts look very different than other types of the other genres we're about to talk about. These accounts are not trying to find friends. They're not trying to build a big following. They don't tweet a lot. They just follow certain people in order to push them off the platform. We also have cyborg accounts. We've already talked about these. These have both human and computer interaction and are, to some extent, are able to beat some of the bot detection algorithms that we have out there today and that Twitter employs in their architecture. You have chaos bots. What these do is they produce a whole bunch of tweets, they almost randomly retweet. And what they're going to try to do is hide a signal in the noise by retweeting a whole bunch of different content from sports, celebrities, all kinds of different content. It's hard to tell what this bot is trying to do. Within that, a lot of that huge volume of noise, they can hide in signals and still be pushing on their information lines of effort. Amplifier bots focus on certain individuals or topics and try to amplify those. Coordinated bots work together to push the same content and oftentimes the same time. And finally, social influence bots work together to try to seem like they're a natural occurring group of people that are conducting something. This is, in this picture here, is a Bitcoin scam. The bots work together to try to make the scam look legitimate. In order to tackle this problem, we've introduced a suite of tools that we call the Bot Hunter suite of tools. This is a tiered suite of tools we'll get into a little bit. It is able to scale to very large data, and it's able to run on the existing data that researchers also have so that they don't have to return to the API to conduct bot detection, which is a huge limitation of existing tools today. It's very accurate, and we'll get into a little bit of the details here in the next few slides. The main goal here is we identified is as we came into the scene, there's lots of other folks and teams that have focused on bot detection. One of the most prominent methods that's being used today is produced by the University of Indiana. It's a great tool. Originally it was called Bot or Not. It's been rebranded to Botometer. While a great tool, the problem is it can only do a few counts. It has it can only do about, I think it's about 200 accounts every 5 minutes, which is hard to do large streams when you have that type of overhead. In fact, when the Pew Research Center and RAND Corporation conducted bot detection and bot studies on large streams, in both cases, these very renowned organizations had to sample their data, oftentimes only taking 1 or 2% and only running bot detection on the 1 or 2%, and then trying to project statistically or infer those sample statistics onto the population. Our view is that we need something that can scale to the entire forest and not just sample a few trees. So that's one of our goals. For that, we have tiers 0 and 1, which I'll define here in a second, are able to analyze forests. Tiers 2 and 3 are able to have higher accuracy and focus on a few trees. Here's the description of the tiers, which I just alluded to. For those who are familiar with the Twitter API, this will make a little bit more sense. For everyone else, I'll try to make it, try to summarize this shortly. Tier 0 is where I haven't even gone to the API. I'm not pulling any Twitter JSON. I just have either a screen name or the tweet text, and I'm trying to do bot prediction based on that limited data. Tier 1 is when we have the basic tweet JSON for a single tweet. That includes the user object and the tweet object, both of which I can extract features from and conduct feature engineering. Our Tier 1 is our primary model that we often use. It can scale to large streams. We've been able to do upwards of 20 million accounts in a 24-hour period on a single thread. On Botometer, it would take 30 days with 30 threads to do that same task. Tier 2 is when I not only have one tweet, but I have all of tweets in the timeline up to about 3,200. Once I have multiple tweets, I can start analyzing additional features, particularly content and temporal patterns. And then finally, we have tier 3. This is our lots of data. This not only includes your timeline, but all of your friends' timelines, which helps us produce the entire conversation around an account and allows us to focus on much of the network patterns in that conversation. This is very accurate. It's also very hard for a bot puppet master to manipulate these network features. However, you can see it's very expensive. It takes about 5 minutes per account to get the data to conduct this prediction. This can only be done on trees, not necessarily forests. These are the cumulative features that we fed into our random forest model. The features are broken down by user features, such as that which is not whether or not it's a default image, content features, such as the average and max number of hashtags, network features, such as the number of friends or number of civilian ties, and then temporal features, such as the inter-arrival time between tweets. The random forest works on a concept of a large number of uncorrelated decision trees, each voting in an ensemble model, which will outperform any of the individual trees. And we found this outperforms other machine learning models that we've tested against. You can see here that this is cumulative. In other words, when I'm using tier 1, I have tier 1 and tier 0 features. When I'm predicting at tier 2, I have the whole bottom half, tier 2, tier 1, and tier 0. And finally, at tier 3, I have all features in the triangle. Because we're using supervised machine learning here, we need some annotated data. Historically, dating back to about 2010, 2011, researchers have used bot honeypots to identify labeled data for bots. This doesn't work as well 10 years later. Other researchers have used manual labeling, which is very expensive. And then some have gone to purchasing accounts, which is a little bit in the gray area because they're purchasing bots on the black market. Which once again, like I said, making a black market purchase puts that research a little bit in the gray area. We've developed 5 novel ways to label data. For the sake of time, I'm going to just quickly go through these. The first is to identify a known bot attack in a way that we can extract the data of the attack. We were able to identify an attack on the DFR Labs and NATO in 2017. And we were able to get 20,000 accounts that were participated in that attack. 96% of which have been suspended, which validate our labeling technique. Speaking of suspended accounts, we've used that of just being able to collect suspended accounts. Many researchers haven't done this in the past because the challenge of collecting suspended accounts is the fact that they're suspended and the data is no longer available. To get around that constraint, what we were able to do is collect the Twitter 1% sample for 3 to 6 months. We then went back and rehydrated the user IDs that were present in the sample. As we tried to rehydrate, we identified those accounts that had been suspended. Once we identified an account that had been suspended, we set aside that data from which we can now extract features for our feature engineering. We've used external unsupervised models that we haven't developed, but have very high precision. The primary one we've used for this is the DeBot algorithm. It's an unsupervised model that finds coordinating bots, very high precision, very low recall for bot prediction, but we use that high precision to label coordinating bots and use those then as a labeled data set. Snowball sampling, this works for both human and bots. Once you get into a highly dense bot network or human network, you can snowball sample out and have a fairly confident that you're getting lots of humans or lots of bots respectively. And finally, find purchased accounts. As I mentioned, other researchers have purchased bot accounts on the black market. We didn't feel this was fully ethical. And so we've tried to find a way to identify these purchased accounts. What we've been able to find is that many of these accounts, when they are purchased, will post a tweet, new owner period, which is very peculiar. And most people aren't going to just post a tweet like that. And so we've gone through our large set of Twitter sample, as well as used the REST API to identify accounts that post new owner period. We've set aside their tweets and the accounts and I've labeled them as purchased accounts. We've manually sampled from them to verify that yes, they do appear purchased and they do appear to be a bot. And this is a very new and emerging data set that we have for labeled data for bot prediction. And the final way we label data is to actually use our tier 0 model. So we have a logistic regression model primarily trained on character n-grams with a few other features you see listed here that is able to identify whether a screen is a 15-digit randomly generated alphanumeric string, which we found is always associated with suspicious and bot accounts. We've not found a single soccer mom that uses a 15-digit randomly generated alphanumeric screen name for their screen name. We've been able to find millions of these accounts, which we can not only use this algorithm to classify these type of accounts, but once we know, now that we know that they're almost all suspicious, we can use accounts that have this string as labeled data and then pull features from the much bigger data set that we have from their data. Now moving on to tiers 1, 2, and 3, we've evaluated them here with 10-fold cross-validation with ROC AUC as our primary metric. This is with an out-of-sample trained test. Notice here that we have tier 1 is, with the more features we have in tier 2 and tier 3, they perform a little bit better in sample classification. However, you see that tier 1 is still at a ROC AUC in the upper 80s, around 0.87, which we believe is good enough to, particularly when you can now use that algorithm at scale on forests. What we've also found is that the tier 1 model doesn't overfit quite as much as tier 2 and tier 3, which means it's able to generalize to new data better than the tier, as well or better than tier 2 and tier 3. On the right, you see that because we're using a random forest model, we can look at the predictive importance of each of our features. And looking at our tier 3 model, we see that some of those network features are our strongest feature. And the power of our tier 3 model, with those network features, it is very hard for a bot puppet master to manipulate those. For example, at the tier 1 and tier 2 level, something that we're getting strength on is, for example, the inner arrival time of tweets or the amount of friends or followers that an account has. But those are fairly easy for a bot puppet master to change if they have a large bot army. However, it's much harder for them to go figure out, how do I change the graph between the centrality or the Similian ties in the conversational network that I'm embedding in? That's a very hard task for your average bot puppet master to begin to try to understand, let alone manipulate. We wanted now to compare against the state of the art. The metric we're using here now is the F1 score. What we found in the past is many bot predictions used accuracy. However, the problem with that is they were focused on precision over recall. We wanted to have a balanced approach to increase the recall because we wanted to be able to find a lot more bots in the streams that we analyze and not just have a high precision with low recall. Therefore, we're using the F1 score, which is your kind of balance between Arminian mean of balance between precision and recall. The two blue bars you see here are external models. They're the bot model I just alluded to is a small bar there. It's a unsupervised and the only unsupervised model you see here. Batometer is the main one we're comparing against. It's a supervised model, and that's the blue bar at the bottom. The yellow bars you see are tier 1 models. The gray bars are tier 2. The red bars are tier 3. Each of the tiers is conducted against a variety of data sets. As you'll see, the type of data sets you train on matters. You can see across all 3 tiers, we have models that are beating the state-of-the-art performance. And all of this is conducted, by the way, on a test set that has not been used for either bot hunter or batometer. So we basically find an independent, manually created bot data set and human data set that we're using to test on, so we'd have unbiased comparison of these models. The training data matters. What I have here is I've taken one of our models. This is a bot hunter tier 1 model. Trained on suspended data. So it's been fed data to train on that Twitter suspended. And the primary reason that Twitter suspends accounts is because of automated activity, i.e. their bots. And now I've used this model and I'm predicting on 3 different bot data sets. All 3 of these data sets are 100% bots. On the left, you have coordinated bots identified by the bot algorithm, which has over 99% precision. So these are all for sure bots on the left. In the middle, you have intimidation bots that we found attacking freelance journalists in Yemen. And on the right, you have bots, scam bots that are pushing this McAfee Bitcoin scam. The plot is of the probability distribution we have of all these bot accounts. So in the probabilities close to 0 indicate they're likely human. Probabilities close to 1 indicate that they're likely bot. Once again, these are 100% bots, so most of our probability distribution for all 3 of these should be pushed to the right of the graph. What you see here is that's for sure the case in the intimidation bots. This bot hunter trained on suspended data is able to have high performance on the intimidation bots. A little bit less so, but still fairly strong performance on the McAfee Bitcoin scam bots. If we were to have a threshold for predicting bots of, let's say, 0.5, majority of those would be captured and we'd be performing fairly well. On the far left, though, those coordinated bots, our algorithm is not performing well identifying these coordinated bots. Underlying that is probably also means that Twitter is not suspending these coordinated bots, which many of them may be commercial, and maybe they're not suspending these, but they for sure are not identifying suspending these, and our algorithm is not able to find these type of bots. In fact, you look at the majority of the probability, weight of the probability distribution there is actually saying that there are many look like they're human. So the model matters. We haven't just done this one model in these 3 data sets. If you see here, I move to the next slide, the 3 graphs we just looked at are highlighted here. I'll get rid of the gray, and you can see we've done this for a bunch of models across a bunch of different data sets so that the analyst can understand how the models are performing on different types of data. So as they get a given data set, an election data set, an intimidation data set, the followers of a national security account or some other type, they can look at how the models are performing and choose the right model for the right type of data. So the training data matters. There's not a one-size-fits-all best bot model trained on one set of data that's going to generalize to every other genre of bot data. As I transition or finish up bot detection, I want to highlight that these models are great for outlining a campaign. And they're great. We're running them right now on coronavirus COVID-19 streams as we speak. So with that, I want to kind of transition to our next thing, which is looking at meme detection. We've primarily published this in a journal article in the Journal of Information Processing and Management. When we first started doing this, we were laughed at. Why are we going to just try to pull memes out? What can you learn from memes? And the power of memes, I want to start with a quote from Adolf Hitler. He said, "I use emotion for the many and reserve reason for the few." Memes are ways to use emotion to elicit a certain reaction. They oftentimes combine a image, oftentimes humorous, that tries to communicate with a certain target audience in their culture with a very savvy text, and the combination of those 2 things tries to get a narrative to stick with the target audience. Memes, entire dialogues today are happening in memes, and those dialogues aren't just with a couple high schoolers. Those are national leadership at the very national level are in conflict with memes with leaders of other countries. You can see here from a quote from Doyle Canyon, memes are replacing nuanced political debate. We see that across the world today. And the power of these is highlighted in the fact that several authoritarian states, and honestly, even the EU, have started to restrict the use of memes in social media. So let's take a look at an example to understand how powerful these are. Let's look at compare a Russian meme with a PR campaign that NATO conducted. You see here is Lasse Montberg. He became the face of Trident Juncture 2020 exercise, a multi-million-dollar exercise, the largest NATO exercise ever to take place in NATO, in Scandinavia. As that exercise initiated, the big effort, the main goal of the exercise was to communicate to the world a strong, unified NATO in the face of a rising Russia. They needed to get that message to move in social media. They chose this Instagram celebrity to be the face of it to try to get this to move across social media. As we look at this image, which became one of the primary images they used within the PR campaign, the little pictures you see here are the kind of thumbnails of that I found by doing a Google reverse image lookup to see where this image moved in the internet. It moved it to about 5 different languages, which isn't bad, not a bad campaign for this PR campaign by NATO. So now let's compare that to a Russian meme. This is a meme that came out just slightly earlier. You have here on the top what is in fact the defense ministers of Sweden, Norway, Netherlands, and Germany at the time the picture was taken. On the bottom is the defense minister of Russia. All of this is true. There's no fake news. At the time both of these images were taken, those were indeed the defense ministers of those respective countries. You see here the main message is a strong Russia in the face of a weak EU, kind of counter to the message we just talked about for Trident Juncture. Underlying that whole message is this anti-feminism message, which is a very prominent message in Russian social media, in Russian propaganda, I'm sorry. Let's see how far this message traveled. Here's the thumbnails of just that image. And the thing about memes you got to understand is memes propagate through evolution. When Richard Dawkins originally coined the word meme, it was to define a cultural artifact that propagated and evolved as it moved through a culture. Internet memes meet that definition and they evolve. So remember, the Thumbnails you see here is just the image we just saw. Let's see how this evolves. First, you see here how it evolves. We've added Iran and China now, once again to the same backdrop, a little bit different image on top. This, you can see on down here, the thumbnails that this image moved, just this evolution of the original image moved more than the original PR campaign by NATO. Once again, all the same messages still reside in this image. Strong Russia, strong other nations in the face of weak EU and NATO, all built on this anti-feminism narrative. It moved to Poland. This is just one of many different variations that went viral in Poland as Poland added their defense minister. Once again, even with the defense minister of Poland added, all the same messages of strong Russia, weak EU are still maintained in this evolution of the original meme. Once again, you see the icons where this went. This is just one of many different variations of that one with the defense minister of Poland. It then jumped across the Atlantic. We still have Poland. We have the original one now, so we've added a mass to this. This propagated across the United States a little bit. And then finally, it was added extreme, hateful, racist, and destabilizing language, which we're not sure how far this went because it was probably blocked by Google image reverse lookup. So you see here that the evolution of this is memes, if they're tailored right with a certain message, can evolve and move to many different places on the internet and at a very low cost compared to a multi-million-dollar NATO exercise. What we want to do is we want to propose a way to detect these memes at scale. So in other words, in very large social media streams, we want to be able to pull the images and be able to identify what are the memes and what are not memes. In other words, we want to classify these memes in the context of other images that have text. Here's the two types of memes that we're primarily focused on. The type A meme on the left is using white impact font over the image. On the right, you have a type B meme, which is black font over directly over an image. You can see here both are used, in this case, by Russian overt propaganda. On the bottom here, you see the same type A meme, in this case used to try to make fun of, first of all, make fun of Black Lives Matter, at the same time very subtly saying that the US soldiers, there's people in the world that US soldiers don't care about. On the right, you have a attack against the far left, trying to make them look like Nazism. So both these types of memes are used extensively in information operations. We're going to develop a technique to classify these. We want to do that with a multimodal supervised deep learning model. To do that, we need to first identify training data. We scraped these type of images from a variety of different social media feeds. We also found non-meme images. In this case, we needed to make sure that our non-memes all had text. If we didn't, our algorithm would learn not meme versus not meme, but text versus not text. To do that, we used an efficient and accurate scene text, or the EAST detection algorithm, which we found performed better at identifying text in images than the OCR approach. We also found that we needed to remove document images. So sometimes like legal documents or other black and white over black text over white background are shared, which tended to confound our algorithm a little bit. These were removed both for training and for production. And we did that with a simple heuristic, RGB over 3 greater than 220, remove these largely white documents. Next, we needed to lift the text off. Remember, we're going to try to do a multimodal deep learning in which we have both text, vision, and face detection combined in a multimodal approach. To do that, we need to lift the text off the image. So with this being the raw image, our first goal was to try to use Google Tesseract, the primary open source OCR that exists today. You see that it fails miserably here. The reason it fails is because Google Tesseract is primarily trained for black text over white background. These memes are white text over black or dark background. So we need to do some pre-processing. To do this, we convert to grayscale. We binarize to black and white, 0, 1s. We do a bitwise flip, flipping zeros for ones. Now we have black over white. Google Tesseract now performs fairly well. We still have some noise in there, but we have most of the signal that we've been able to extract. We now have added a post-processing to our pipeline that removes most of that noise, and we have our full signal. You see a couple layers there, but we have the full signal here that we can now bring into a multimodal deep learning or into topic analysis as needed. Here's our multimodal deep learning model. We have the text which goes in the LSTM at top. We have images which go into the vision that you see there. And then we have the face encoding, which we extract with the face recognition package developed by Adam Geitke. All those go into get concatenated, go into the fully connected layer. And then we have softmax going into a meme, not meme prediction. All this is trained with cross entropy loss with certain hyperparameters tuned. Here's our final results. You can see the best model in the text is a deep learning model, that LSTM, which gets us an accuracy close to 0.8. Under the vision models, the very first one you see there is the SIFT Bega visual words. That's a scale invariant feature transform with the Bega visual words. That's the last model that we kind of had, or one of the best models pre-deep learning era. You can see it once again has an accuracy close to 0.8. The rest of the vision models are deep learning models with VGG, ResNet, Inception, as well as a custom one that we've designed. All of them give us accuracy moving into the 0.9 range, with Inception giving us well over 0.95. We move to multimodal, they bump the performance up slightly, up to 9.96. Although we want to highlight that once you add certain languages of text and certain faces, it becomes unique to that situation and doesn't generalize as well. So you get increased performance, but you must train that in the context through which you're going to use it. If we generalize, we generally just go to new context with the Inception version 3 vision model that you see here. We want to compare against the state of the art. So this is a model that MIT developed to find memes. A team there developed, to find them, they primarily use templates. So a lot of memes are templates, like you see here, these the certain images that are oftentimes used for memes. If we identify images that have those in the background, then those are likely memes. You see doing that, we look here at this template-based algorithm, they have an accuracy of about 0.87. The problem is they have very low recall through two different data sets that we manually labeled and tested this on. One from the Swedish elections, one from the US midterm elections in 2018. Our goal is to increase this recall here. You see for both our vision models and our multimodal models, we've increased the recall up in tenfold, up to approximately between 0.5 and 0.6, without having too much drop in the accuracy for both data sets. Both accuracy is still in the 0.8 accuracy range. So we think that's fairly decent for using this model to extract large amounts of memes from these large data streams. You can see here we can now put this in production. This was run against the Russian IRA data released, suspended and released by Twitter. 9 million tweets, 687,000 unique images, 46,000 unique memes that we can extract. By unique, I mean that they have a unique SD5 hash. Here's run on the Canadian election against, once again, a very large data stream. These we were able to find memes and attack vectors that are trying to manipulate both the conservative and the liberal political sides of Canadian politics. These are part of memes in the Hong Kong protest. Historically, China has been not as much use of memes. Partially, we believe the reason is because memes evolve outside the control of the state, and China likes to control those narratives very closely. So they don't want to risk these memes being able to evolve outside the control of the state. However, as they go into a more combative, we see them moving to potentially taking more plays from the Russian playbook, in which case we'll see more and more memes emerge. The beauty of memes is that once you identify large groups of memes like we have, you have them now in a directory. By looking at memes, particularly for the Russians, you can very clearly put these memes into their lines of effort and kind of highlight what their lines of effort are and what are the different things that their campaign is trying to accomplish. You may even be able to identify the target audiences based on the cultural relevance of the memes that they choose. We also wanted to map the evolution. As I said, memes propagate different than other media. They propagate primarily through the evolution of the meme and not through normal virality means that other viral content moves without being changed. You see here, this is, if we take the last layer of our deep learning model, we use that as an embedding for the image. We then do a radius nearest neighbor search using a brute force algorithm. We're able to identify the evolutionary tree, in this case for the 2018 midterm elections. If we zoom in here on this, you're able to see that this is a Tom Hanks meme that is popping back and forth. And these are connected by links in our evolutionary tree, and it's hopping back and forth between, in the bottom left, you have The Democrats here producing one, Republicans fire back with one, Democrats respond with another, all evolving on the same meme. In this case, it's hopping back and forth between conservatives and liberals. At other times, we say staying within, evolving within the liberals or within the conservative political parties or political groups. We're able to conduct further analysis because we have face detection. We can identify memes by face. I want to highlight that these are both, memes can both support and attack certain individuals, and those are all combined here. So when you see a certain political individual here, those are combined both positive and negative memes about that individual. By combining the red and the blue, we can look at memes by party as well as try to break out sentiment by the individual. We can also, because we've extracted a text with our OCR meme extraction, we can now try to bend the text. For the 2019 Canadian political election, we were able to take this using a LDA topic modeling with a K of 3. We identified 3 different topics here. You have topic 1, which is primarily your conservative conversation. Topic 2 is primarily your liberal conversation. And immediately 2 weeks before we pulled this data and conducted this embedding or LDA analysis was when their prime minister had a very, some media release of something that he'd done earlier in his life that was very prominent, lots of memes conducted against that, and that it kind of all got bent into topic 3. So we can conduct this further analysis on the semantic content shared in meme images. Those are just 2 of the algorithms we've used. I do want to highlight a couple other models. We've characterized Chinese and Russian disinformation. We've looked at agent-based simulation to look at the bend forms of maneuver. That was published in the winter simulation. We have a bot match algorithm, which supplements our supervised model. This is a semi-supervised model that kind of fills the gaps. And that's in review right now by the Digital Threat Research and Practice. We have random string detection, which we've briefly talked about. Sketch.io can sketch a campaign out. And then bot labels helps us characterize the campaign using similar heuristics to a human analyst. And finally, the bot field guide is used as a way that we kind of have a field guide similar to an animal field guide that people can look at, whether that's analysts, journalists, or just your average citizen, and understand these bots and the manipulation they conduct a little bit better. With that, we'll just dive very briefly, for the sake of time, into COVID-19 initial results. Here's our social cybersecurity we generally use. We stream and filter data. In the case of COVID-19, we've been streaming most of the COVID-19 related tweets since the 29th of January, so well before it began hitting the Western countries, and particularly the United States. We then explore that data. We classify it using Bot Hunter as well as a variety of other tools that our lab has. We begin characterizing it with Sketch.io, Bot Labeler, and some other algorithms. We begin aggregating that to have a full understanding of the campaign, try to summarize what are the primary narratives and the target audiences, if we can identify. If we can, try to conduct attribution on who the entity is behind the campaign, and finally evaluate its success. For COVID-19, we've just conducted a few of those initials at this point, so right now we're just showing you initial analysis. Here's 1 day of COVID-19 conversation. This is just the retweet network for 1 day of the COVID-19 conversation, and this is us streaming, filtering on many different COVID-19 related semantic terms. We can take this network then, and the first thing we do is try to find who is influential in the network. In this case, I've measured importance by both the mention network and the retweet network using eigenvector centrality, which identifies those individuals which are connected to other important individuals. In the case of both of them then, I've run Bot Hunter to identify those accounts that have bot-like characteristics. I haven't necessarily manually gone through and verified, but these have, and we've sampled a number of them and haven't found one yet in this data set that we've mislabeled. That is, we're not saying there aren't any, but we're fairly accurate from just manually checking both of these. You see here in the mention network, and in particularly the retweet network, very high number of bot-like accounts that are propagating various things in this stream. We also just a couple of days ago, we looked at bots that are attacking experts. So these are attacking experts that are advising senior leaders in the United States. And we noticed in the 5th of April, there was a surge of attacks that are conducting this attack against expert advisors. You can see some of the hashtags in the bottom right that they were using that we used to filter this out. This was a huge surge of up to 45,000 tweets that we had just 2 days ago. when we run Bot Hunter, 69, almost 70% of these had bot-like behavior. So you can see this very coordinated attack against expert advice, expert advisors in the United States who are advising the senior leadership. We also found a bunch of memes associated with this. So many of the memes, though, were actually attacking it. So many of the memes were used to attack the campaign and actually support the advisors in this, which was just kind of a unique thing that we found, is memes used to kind of counter this information attack here. Here's COVID-19 meme hunting. A lot of these are just humorous memes that we were able to extract with Meme Hunter. You can see some information operation campaigns conducted. The BIM thing we recently used Meme Hunter on was just yesterday. We ran it on the Cal Exit. So just yesterday, Iran conducted a very large surge. They do this about annually, where they conduct a Cal Exit campaign against the United States. You can see here that they've created tons of different memes, a part of this campaign that they probably pre-established and then surged on this yesterday in order to try to push this idea to push California out of the Union. So you see this largely being propagated by Iranian bots in a campaign against the United States. Once again, this was extracted largely with Meme Hunter, with some manual labeling on the side to pick up a few of the stragglers. We also looked at state-sponsored media. We do this with an algorithm I didn't have time to go through. This is part of the bot labeling. We have something defined state-sponsored media, or what a lot of people would call propaganda. Here's some of the handles we search on, whether we have a ton of these handles that we're searching on. We do acknowledge that not all of these are the same. So Voice of America Africa is very different than Sputnik International. But we do want to highlight how much of these types of accounts, from which countries, are participating in certain streams. So we run that on the state-sponsored media for COVID-19, excuse me, for all of COVID-19. We extract those accounts that are propagating or retweeting or mentioning state-sponsored media. We found here the top 50 accounts that are propagating state-sponsored. You see the first one there. All of these have bot-like characteristics. A couple of those aren't bots. So the first one is actually a news agency. The second one I'll show you in the next slide, but the rest of them have very much look like bots. So lots of bots are propagating this state-sponsored, trying to push this within the COVID-19 stream. You can see on the bar chart on the bottom, the largest amount of these is bots pushing Chinese social media. We have a bunch pushing Russian social media, and the rest of them with numbers there. You can see examples of a couple of these here. So one of them is not necessarily a bot. This is allegedly a representative of the Chinese government. The Chinese ambassador to Venezuela has the highest number of state-sponsored mentioned retweets at 769, just related to COVID-19. You see examples over here that he's tweeting in both English and Spanish, and in particular attacking the United States administration's management of COVID-19. Here's one that's trying to mimic. You can see here on the left is an account that is critical of Chinese leadership. It's at CT Lao 2. We were able to find at CT Lao 3, which was trying to copy that original one that's critical of leadership and just have one digit off. This one has retweeted Chinese state-sponsored news 759 times, particularly countering and spreading disinformation. You see here that it was the coronavirus is related to U.S. bioweapons research at Fort Detrick, Maryland. Russian bots are pushing the kind of traditional propaganda. You see here, this is translated post here where it's trying to say that the Italians are replacing the EU flag with the Russian flag because of Russian support for Italy during the COVID-19 crisis. This was pushed by the Sofia Sanchez Media, which is with 60,000 tweets, is a high likelihood of being a bot. These bots are pushing these for the Russian propaganda within the COVID-19 streams that we're collecting on. Finally, it hasn't been all success. We're able to identify, in this case, this is an account you can see here that's been pushing Chinese propaganda and Chinese state-sponsored. You can see here that Twitter is targeting this and possibly thinking that it's suspect. For this case, this account has tried to go offline for a while because Twitter is starting to suspect it of so Twitter is trying to crack down on these, and you see this account is having to go underground because of Twitter getting after these types of accounts. And with that, just a few closing comments. I know I'm short on time. We've published this in a number of different things I've already identified. We do have operational code on the right here and a number of different packages to conduct these operations if you reach out to us and ask about it. We are Dr. Carly and I are in the process of publishing a book which highlights a number of the research that we've highlighted here today. We'll hopefully work with Springer over the summer to get this into publication. So look for that in the near future. And finally, I do want to highlight, in my mind, there's 3 big buckets of research that we need for the emerging field of social cybersecurity. On the bottom left, we have the policy. We need lots of policy looking at industry policy. We need policy focused on should there be red lines, should there not be red lines, freedom of speech, as well as a variety of other things that we need to identify within this idea of social cybersecurity. You can see there in the top, we have the research focused on identifying and understanding a threat, which is primarily where my research has fallen. And then on the bottom, we have to figure out, once we've identified a threat, how do we mitigate and neutralize that threat? And I've only barely scratched the surface on even a few ideas in that. There's a lot to be done in the idea of mitigating and neutralizing a threat. There's still a lot to be done in identifying and understanding it. So with that, we just want to highlight that this is just getting into this idea of social cybersecurity. We look forward to your questions here in the next few moments.
So, David, how did you discover the Iran one?
Actually, the Iran one was a little bit of accident. So I'm always conducting research in this. So as I'm conducting research in the last few days, I just noticed that the hashtag CalExit was trending on the Twitter front page. So when you log on to Twitter, it shows you on the right, what are the hashtags that are trending. And I noticed hashtag CalExit was trending. I was like, why in the world is hashtag CalExit? So I started clicking on it, and sure enough, noticed that this is a huge Iranian campaign. Other people had already, started replying to these and trying to identify these things as Iranian bots. But it was just starting to trend on the front page, showing that this is the trending topic of the day for Twitter, was hashtag CalExit. And so after I saw that, I immediately started getting the main hashtags and going into our pipeline to analyze that attack, so we could grab the data and have it for our team, as well as just understand it for the greater audience, everyone listening here, as well as others.
That's great. Thank you.
Thanks for this great presentation. I wanted to know if you had access to the field guide that you could share with us. Is it a link? Is it a PDF? I'm interested in all of your publications. It's going to be hard to extract them from this. Can you send a separate email or chat to us about that?
Yes, the actual field guide I have in PDF, but that'll have to be released by Dr. Carly, and I'll let her answer that in just a second. I will say most of my publications are available if you just look me up on Google Scholar, a lot of them with links are posted there. I also have a web page I can send that have a lot of with links to the actual publications.
Okay, great. Thanks.
Talk a little bit about the differences in recall and precision and accuracy, and kind of what are you looking for there? Just kind of defining those terms a little bit.
Yeah, so for those who aren't familiar, so precision is just looking at how many of the ones have I labeled as true, are they really true? So, how much of that. Recall is looking as how much of the total malicious accounts have we been able to find? Those are slightly different, and they're kind of competing. So oftentimes when we focus on precision, it's at the cost of recall. When we focus on recall, it's at the cost of precision. With a lot of models, Batometer and some others, we've also seen that you saw in the MIT mean prediction, they focused on precision and were able to get fairly high precision. Those have pushed, when you get high precision, it can also push your accuracy up, because accuracy doesn't fully capture the contribution of recall. So it pushes those numbers up. But the problem is when I'm trying to pull out memes from a stream or bots from a stream, so let's say COVID-19, when I want to run bot prediction, I don't want to tell people, hey, I was able to find 5% of the bots. I want to be able to say I found 50, 60, 70% of the bots in this stream. And that's why we want to push our recall up to say we're able to find. Now that's sometimes at the cost of precision. So we try to find the best balance of that, but we, in all of our algorithms, are trying to push the recall up because we're conducting this at scale. We also can have some other algorithms that we develop to kind of winnow it down. Once we can set aside all of the memes, all of the bots, all of the malicious accounts, or other algorithms other people on the team are developing to look at trolls or other things, we want to just have a pretty high recall and not just say we're really accurate, but we only found you 2% of the bots in the stream. Does that make sense?
Yeah, absolutely. Thank you.
Hey, like the talk. So I noticed back when you were doing the topic modeling with the LDA, you'd identified where there were some relationships to Canadian politics prior. And I saw you'd also done some network analysis there, which is pretty cool. But have you linked in any other kind of like time series analysis with these as far as seeing like what predicts evolution of the memes at all, or the directionality of the memes?
I've not looked at time series analysis, to be quite honest. I mean, we looked at the trends, just volume trends of these things.
Right.
I've always looked at that, but that's the extent of kind of time series analysis.
Gotcha.
And you know, that's always driven by events. It's not necessarily cyclical or seasonal or anything in that. It's very event driven in the social media streams. We look at the time, volume time, but not necessarily time series analysis.
Gotcha. So then I guess the following question. So you'd noticed that it was related to the Canadian politics. So how did you identify that? Was it right? So you were like with the Trudeau, yeah. So,
well,
hey,
so I mean, we take these and we apply them on. So you know, our step one. So here, it really starts in that firm stream filter.
Yeah.
So there's a lot of tools out there that are running on the entire Twitter stream. And the downside to that is I have to now filter the entire Twitter stream, and I can't do what you just saw. But because we start with a connecting to the streaming API, we put in our hashtags that we're searching for. So COVID-19, we have about 15 of the prominent hashtags we're searching for. Most of the conversation involves some of those hashtags or some of those specific terms. Sometimes it's not a hashtag, sometimes it's just a term, just COVID-19 without a hashtag in front. So we're able to capture a large part of that conversation. In the case of Canada politics, we were streaming a bunch of the Canadian prominent hashtags for the politics, both the liberal side, conservative side. Honestly, we probably didn't have some of the really small political entities and parties in Canada. But now that we have and can say this is the Canadian stream, we can then run this and be able to know that this is all associated because of content to the political conversation in Canada. And that's how we kind of delineate that part of the Twitter conversation. Does that make sense?
This isn't a question so much as a congratulations from Rebecca Goolsby. Dr. Beskow. It was an excellent presentation, and you'll be hearing from us again about Sketch.io and all of the other kinds of products. You really want to, and the bot field guide and all of that other stuff. We really want to leverage those in our APAM project.
Great. Thank you very much, Rebecca.
Congratulations. Great job.
So first off, thank you, everybody. Thank you, David, for an excellent presentation. And please stay tuned to the channel. We will keep hosting these roughly every week in the area of informed democracy and social cybersecurity. So thank you all for joining us. And if you have any questions or any follow-up things, please send them to me. Lisa, please reach out, and I'll make sure we get you all of the papers. And anyone else who wants them, please reach out to myself or to David. Thank you. Thank you all. Have a good evening and stay healthy and happy.